All right, let's learn how to count to F. How do we count to F? Well, pretty simple. We do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. What is that? How do I count to F? What is A? What is B? Those aren't numbers. Well, they are in the form of hex codes. So hexadecimal is a number system representing half of a byte as a single digit. It's referred to as based 16. If decimal is based 10, binary is based 2, hexadecimal is based 16, where each digit has 16 possible values. From 0 to F, what do these actually represent? Well, you have your regular numbers, 0, 1 through 9. Then A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. We represent a hex code with like a OX or a hashtag, a pound sign in front of it. OX18 or hashtag FA. These are hexadecimal numbers. OX18, this is not 18. This is not the same as 18. It is not 18 because it's actually going to be 24. Let's learn how to convert. This will help us better understand how to read hex codes. Here we have OXF, and I have this value of 1 underneath it. Looking back at the previous table, F is 15. So OXF is 15. What about this? OX2F. We know that F is 15. But what is this value going to be? Well, that's going to be 2 times 16. We take this value and multiply it by this value. So 2 times 16 is 32. Then we add them up. 32 plus 15 is going to be 47. So OX2F is 47. Let's do some more practice and we kind of see how this really shakes out. Well, OXF, we already had that, so that's 15, easy enough. What about this? OX10. This is not 10. This is not 10. It's not 10. It is 16 times 1, which is 16, and 0 times 1, which is 0. And then we get 16 plus 0, that gives us 16. So that's our answer. What about this one? OXFF. Well, F is 15. We know that from the previous table. We do 15 times 16, which is going to be 240. And then we do 15 times 1, which is 15. So 240 plus 15 is 255. You may recognize this number. It's going to be important later. What about this one? 1D, OX1D. Well, 16 times 1 is 16. D times 1. Well, what is D? Well, A is equal to 10. B is equal to 11. C is equal to 12. D is 13. So this is saying 13 times 1 is 13. So 16 plus 13 is going to be equal to 29. What about going from decimal to hex? What about going the other way? This is going to get a little more complicated, but you take the decimal number divided by 16, that's your first digit, and your remainder will be your second digit. So we have 188. How do we put this in hex? Well, we take 188 divided by 16. It's going to be 11.75. So our first value is going to be that 11, and then the second half of it will be that 0.75. How do we represent that? Well, first off, we break it in half, using the decimal point as our divider. 11 is B. We know that from our chart. The second half is a little more complicated. We take our 0.75 times 16. So 0.75 times 16, that is going to be 12. We know from our chart that 12 is C. So we know that 188 then is OXBC. I went through this fairly quickly because there's actually an easier way of doing this. Though it does involve extra steps, but it's actually pretty straightforward. We'll learn that about it a little bit later or in a different video. But why? Why learn about this? Why is this important? Why is this useful? Well, the reason for a hex comes down to a simple thing. Which of these is easier to read? 11010100 or D4? It's D4 that's easier to read. Less chances for a mistake. So we use hexadecimal to actually just write binary code in easier to read format. 2 hex digits is the same as 8 binary digits, which is the same as 1 byte. So we can represent a byte using 2 hex digits. It's commonly used for memory locations and color specifically. Those are the most common uses for it in computer science. So this is your chart, or the set of charts really to better understand binary and hex. If you understand these values, if you have these values and can put them out, write them out, you're good to go, because you'll be able to convert most commonly used binary digits. Well, really, you can convert anything that's in byte form. And if you ever forget these values, just for like the binary, it's just you keep double until you run out of space. 1, 2, 4, 8, and then keep going. How about binary to hex conversion? Binary to hex conversion is actually the easiest way to get from decimal to hex, to be honest. How do we do it? Well, first off, we take our binary number, we put it in our little binary number organizer, or byte organizer, but we do a little bit of changes to it. So I'm going to take this left side and I'm going to change it to 8, 4, 2, 1. What we're doing here is we're basically just cutting the number in half. Now your left side, all we do is figure out what these values are. Well, what's 8 plus 2? 10. What's 4 plus 1? That's going to be 5. So we know from our chart that this is A and this is 5, so the answer is OXA5. That's it. So let's try some of these out and we'll get a better understanding of it. I'm going to give it a shot yourself though and see what you can do. All right, so we have our number here. The first one, 10100110. Take this and we'll cut it in half. 8, 4, 2, 1. 8, 4, 2, 1. 8 plus 2, because these have ones above them, is 10. 4 plus 2 is 6. So the answer is OXA6. What about this one? So we take our number and we cut it in half. 8, 4, 2, 1. 8, 4, 2, and 1. Well, none of these have 1 on the side of it, so this is going to be 0. None of these on the right side. Well, we have 8, so we do 8 plus 2 plus 1. This is going to be 11. The answer is OX0B, or just OXB. Either one's fine. What about this one? Same thing. Take it, cut it in half. 8, 4, 2, 1. 8, 4, 2, and 1. Now this side, the answer is going to be 8. This other side is going to be 0, because there's no 1s over here. How do we write this final answer, though? So the answer is going to be OX80. Now, it is OX80, not OX8, right? This 0, the trailing 0, is necessary, right? If you think about just regular numbers, a 2 is not the same as 20. That trailing 0 there changes the value. So you need OX80. Otherwise, you're showing the different number completely. And finally, we have this one. It's going to be 1 plus 8 plus 1 is 9. The answer is OX19. Now, to go from hex to binary, the opposite way, just as easy, honestly. So we have OXC9. We're going to put this into binary numbers. We take that modified version of the chart, where it's 8421, 8421. We plug these in. C is going to be 12. So, how do we represent 12 up here? Well, 12 minus 8, that works. That's going to be 4. 4 minus 4, put a 1 there. 4 minus 4 is 0. And then everywhere else gets a 0. So 1, 1, 0, 0. On the right side, we have 9. Well, 9 minus 8 is 1. So I put a 1 here. Then I can't do 1 minus 4. Can't do 1 minus 2. But I can do 1 minus 1. Boom. So the answer for OXC9 in binary is 11001001. Try it for OX9B. Well, 9 is 8 plus 1. 1, 0, 0, 1. I know I kind of rushed through that, but 9 is 8 plus 1. There we go. What about B? Well, B is going to be 11. What is 11 minus 8? Well, that works, so we put a 1 there. It's going to be 3. Can I do 4 minus 3? No. 3 minus 2? Yes. Gives me 1. 1 minus 1? Yes. Gives me 0, and there we go. So the answer is 1001, 1011. What about OXB1? Well, B is 11. Right? 11 minus 8 gives me 3. So I'll put a 1 here. Can I do 3 minus 4? No. 3 minus 2? Yes. Give me 1. Put a 1 there. 1 minus 1 is 0. So there we go. 1, 0, 1, 1. And then for the 1, we just do 0, 0, 0, 1. What about OXFF? Well, F is 15. 15 minus 8. That works. Put a 1 there. This is 7. 7 minus 4. That works. That's 3. 3 minus 2. That works. 1 minus 1. That works. There we go. 1, 1, 1, 1. And I don't even have to bother doing the math because it's F. So it's just 1, 1, 1, 1. Same as the other side. Which is, fun fact, 255. Which is the largest value for 1 byte. 2C. 2 minus 8, no. 2 minus 4, no. 2 minus 2, yes. Which is 0. Then C is 12. 12 minus 8, 4. 4 minus 4, 0.